Okay, I'm filming this one
Dude, I love
because you guys are so lit. So,
Let's talk about
guys, I think this is a short problem set. It's really not that many. And also, here's what you're gonna like. That there's not a whole lot that I have to teach you that's new. There's a small little technique to solving these. Okay, that's really similar to what we've already done. Okay. And so then once I show this to you, you got the next 4 days in class just to like finish up the assignments. Which I think that's
Sensory
ample time.
overload.
Oh, it's ample time, I think. I'll help you.
We'll work on Tuesday of next week too, right?
I think, but I mean, minimum you have Tuesday, Wednesday, Thursday, Friday. I'll help you with any questions you're stuck on. Okay. I don't think you'll have any trouble finishing this in class. So on this new problem set, the first one says, you might look at that at a glance and go, oh, that's a really easy question, because x squared minus 1 equals 0 is a pretty easy question. But now it just says, basically, for what values of x is the quantity x squared minus 1 bigger than 0? Or positive, you can phrase it that way. So the technique to solving this is just like this. What you do is you pretend, it's not really pretending strictly, but let's call it, we're going to pretend that the question is this. Okay? So we're going to pretend it's an equation, not an inequality. We're going to solve it. What's the solution to this?
1.
1
4 and negative 1.
and negative 1. Okay? Is everyone fine with that?
Yes.
Now remember, the question isn't what values of x make this equal to 0. The question really is what values of x make this greater than 0. So what you do, the technique is to make a number line. And guess what two numbers I'm going to put on my number line?
1 and negative 1.
1 and negative 1. And then what I do is I'm going to think of numbers. This is just a number line of x values. I'm going to think of numbers that live in, how many regions are there?
3.
There's 3 regions. So let's look at the left region. Someone give me a number that's in this region over here.
Negative 3.
Negative 3, great, perfect. Plug it in here. If you plug negative 3 in there, it makes
9 minus.
positive 9 minus 1 is 8. Is 8 bigger than 0?
Yes.
Okay, so this region over here is good.
So you draw a dot.
You can draw a happy face. Just this, so basically what we're saying is, if the x value is in this region,
We're good.
to the left of negative 1, you're good, you're fine.
We're chilling.
How about if x is between negative 1 and 1? There's a really obvious number between them, 0. Or 0.5, sure. Plug in 0. 0 squared minus 1 is negative, which is not bigger than 0. So this region, no, that's no good. Does not satisfy the original question. Again, plug in a number bigger than 1. Okay, how about positive 3 this time? Or how about positive 7 million? Whatever you want. 7 million squared minus 1 is bigger than 0. So, one more little detail. Can x be negative 1 or 1?
No.
If we
that makes it
has to be
equal to
3,
0.
yeah.
Yeah, if you plugged in actually the number 1, it would be 1 squared minus 1, which is 0, and 0 is not bigger than 0. If there was an equal to sign here, then you would be okay. But so what you do is you put an open circle here. Then you shade in the regions that were good, the regions that satisfied the equation.
That is at the or answer.
So yeah, so the answer to this is, there's 2 ways to write it. There's 2 different notations. One notation is to say our x values can be less than negative 1, or our x values can be greater than positive 1. That's one way to write it.
We can do the weird thing.
The weird thing is all numbers from negative infinity up to negative 1 union with all the numbers from 1 to infinity. If you've never seen, has anyone here never seen this notation, the second one? Oh, okay.
Oh, yeah, definitely.
Carefully.
I'm going to stick with the or.
No, you have to know both.
Well,
I'm not worried about it.
These are,
how do you tell if you are including the negative one and the one? Because it looks like to me that you're including.
Yeah, so we'll go over, by example, we'll cover a bunch, but basically there'd be a square bracket. This bracket, if you have this, or I can face the other way. I'll pay extra close attention to make sure we go over this notation since most of you guys haven't seen it.
Okay.
So, but what this says is this is an interval. Part of what can make this confusing is that it looks kind of like a point, doesn't it? There's two values in parentheses, but it's saying include all numbers from negative infinity to negative 1. And then union just means that U is just saying X could live in either one of these. It's effectively an OR. This U is basically just OR.
Okay.
And then all numbers from 1 to infinity. Let's do a few more examples. Let's do the one right below it, because the one below it has a little equal to sign. All right. X squared plus 6x minus 16. Now I'm going to write equal. Well, it is technically this. There we go. That's better.
Oh, we're doing the one below it?
Well, we're just going to go. You don't. So guys, for the sake of time, you don't have to rewrite it equaling 0 every time. Does that make sense?
Factor it.
Yeah, we're going to factor it. So what two numbers add up to 6, but multiply to negative 16? Yep, we got positive 8, and we got negative 2.
This is why I like doing examples.
Why?
Because that would have taken me a little bit.
Thanks. I take that as a great endorsement. Thanks for doing it for me, so I didn't have to think. Wow. Don't trigger me.
We have
Okay.
negative 8 and 2.
Right. So
It's a lot
now.
of brain power for me.
Okay.
Okay, so negative 8 would make this whole thing equal to 0, and 2 would make this whole thing equal to 0. So now let's check our regions here. Now, by the way, when you check these regions, like, okay, for example, let's plug in a number that's bigger than 2, like,
3.
sure, 5, 3, 2, 3, 4, whatever you want. Okay, well, I'm gonna do 5, just for example, 5. People often make the mistake of, here's talking to this whole, like, using your brain power thing. If I plug in 5 into this, right? If I plug in 5, I get 13 times 3. But do I have to really know what 13 times 3 is to like know that it's no? I just bear in mind that if you plug in 5, it's going to be a positive number multiplied by a positive number. So that's going to make it positive.
So it's good.
So that region's good. We like that region. Now let's pick a number that's between negative 8 and 2.
Negative 2.
Sure, negative 2. Plug negative 2 in there and plug negative 2 in there. And what we'd have is positive 6 times negative 4.
So it's negative.
But again, I don't really care about the size of the numbers. I just care that it's a positive times a negative, which is, no, maybe X is the wrong symbol to use. Maybe I should use frowny. Frowny, frowny.
Why are his eyes so far apart?
You may. I think he looks fine. Yeah, he's built different. He's built different.
If we all look the same, life would be boring.
Anyway, plug in a number less than negative 8. How about negative 10? That would make negative here and negative here. The negative times a negative is positive, which is what we're looking for. We want it to be positive. So now here's the difference though. Is 2 a solution?
Yes.
Yes, because if you plug in 2,
It's
you'd have
yeah.
10 times 0, which is 0, and 0 is greater than or equal to 0. So we have filled in dots here. Now here, let's get to the notation. The old style, or no, it's not old, but it's just, this kind of notation would say my x values can be less than or equal to negative 8, or they can be greater than or equal to 2. Using our new notation, you'd go, okay, every number from negative infinity up to -8. And a square bracket tells you that you're including that value. -8 actually does count. So curved bracket means you don't, -1 doesn't count as a solution, but here, square bracket means it does. And then union, look at that. That's pretty neato, isn't it?
It's not bendy.
You thought the,
Yep.
why would it be bendy?
I don't know, because those usually are, you know? Like
These
a,
two loops are usually bendy.
nope, at the end, it's thick.
So
Interesting.
number 2 is similar to that.
Yeah.
By the way, this technique is very general. This is going to work for all the problems on the next page, number 2. It's going to work for all the problems on the next page after that, number 3.
That's cool.
It's pretty neato.
Yeah. Will it work for number
How
4?
about 4?
Yeah.
Maybe.
So I want to. You know what we're gonna do? We're gonna cancely wansley a little group of these problems. Numbers 6, 7, and 8.
Yay.
We're just gonna skip.
Why are there 4 parts?
Well, we're skipping it.
Doesn't matter, Maddie.
Oh, we're skipping all of them?
They're problems that are
Six,
just
seven, and
there to show you how you can represent some inequalities to show.
Can I just rip this page up?
Don't no man, you don't rip it out.
Yes.
Oh my God. Maddie says, "Can you rip this out?" And I say, "Don't rip it out." And then Mime just goes and rips it out. Thanks, Mime.
You're welcome.
I guess if you really want to rip it out, Maddie, you can.
It's gonna
Um,
cause me.
She's a trendsetter, so she's an influencer.
What
So
can I say?
She's an
Unfollow my
Okay,
sister,
so-
like and tag, or like and follow, subscribe.
Okay, I'm done.
We can certainly double back, and if you want help on the inequality ones, we can discuss those. It's fine. tomorrow.
Aren't they like all inequality ones, pretty much?
No, I wanted to jump forward to the rational ones.
Oh.
I don't want
Which number?
a big focus with the inequalities. Oh
9.
my God, Maddie.
I wrote skip on it.
Okay, so yeah, we're gonna look at 9 a little bit because 9 has the exact same technique here, but there's one extra step.
Fractions.
I'm kind of curious if you guys can maybe guess, or not guess, but maybe kind of figure out like, this is all gonna happen for this question, this first question, but there's one extra thing you have to think about.
Okay, is it,
Multiply it times, it's not equal to 0.
does it,
True.
so you can go x minus 2 and set that equal to 0 though, right?
Where'd you get the 2?
Well, like when you,
You plugged in 3 for x.
yeah, like you put x, you multiply both sides by x, and then divide both sides by 3, right?
Did you say X or 6?
By x. Like multiply them by
Yeah.
x.
Well, you're getting a little ahead of me here. That's okay.
Is that not right?
No, you're right.
Oh,
You're right.
okay.
But what I'm trying to get you to look at first before we get into any calculation is, do you see how, so the first step is going to be the same we did before, which is to pretend this is an equation, right? We're going to solve this. So that's the first, it's the same first step, right? You guys see that? So, but there's one other, so when we let's solve this and then I'll get to my point, I guess. So Aslan says we can multiply both sides by x. Okay? And then divide both sides by 3. And you also might have noticed at the beginning, like, oh, well, 6 divided by what makes 3? There's only one number you can divide 6 by to get 3, and that number is 2.
2.
Now my number line that I draw, I'm going to put 2 on it, because 2 is the number that makes these two things equal to each other. There's one more number I got to think about. Come on.
0.
0. Why 0?
Because it can.
Yeah, you see how you can't divide by 0. 0 is important because this question is asking where is this for what x values is this quantity smaller than 3, smaller than or equal to 3? I shouldn't say smaller, sorry, less than or equal to 3. I was saying I shouldn't say smaller because if x was like negative, a tiny negative number, you'd have a huge negative value, and I don't think huge negative numbers are small, but all negatives are less than 3. Anyway, 0 is a number where, what kind of structure on the graph, if you were to graph this, what happens at 0?
Hole.
Huh?
Hole. Damn it, I tried.
It's
Asymptote.
Asymptote. Now, an asymptote is a place where a function can potentially jump from being really, say, really positive to really negative, right? Here, spoiler alert. If I graphed 6 over x, look what happens. At 0, it jumps from huge negative numbers to huge, I say negative, from huge positive numbers to huge negative numbers. That's some pretty intense action, right? So if I'm wondering when is this less than, here's y equals 3, when is this graph less than 3, I certainly have to think about the asymptote, right? That's important. So, long story short, any number that creates an asymptote, put it on the number line. If you totally tuned me out there, just listen to this part. Identify any asymptotic x values, put them on your number line. Now let's test out our values. All right, let's plug in a number that's bigger than 2.
3.
3 works. Plug in 3. Does it make the statement true or false?
True.
True.
True, right? Divided by 3, you get 2 is less than or equal to 3. That's a true statement. So this region's good. By the way, you see on the graph how to the right of 2, it's less, it's lower. Plug in a number between 0 and 2.
1.
Sure, how about 1? 6 divided by 1
Doesn't-
is 6. 6 is not less than or equal to 3. No. And then any negative number. How about, okay, negative 5. Is negative 6/5 less than or equal to 3?
Yep.
Yeah, you probably think about, well, you plug any negative in that, it's going to be a negative is less than 3. Okay, now,
Are they always going to be where it's the two other sides? Or
we'll find one after this where it's going to be like the middle part. That's how you get the glow up. Right, Maddie? Okay, now here, this one's a little weird. What kind of circle am I going to put at 0? Is it
Open.
open, right? Because 0, you ask a question, is 0 a solution to this? No, 6 divided by 0 is not less than or equal to 3. 6 divided by 0 isn't even a number. How about 2 though? Does 2 work?
Yeah.
Yes.
2 works. So 2 is a solid circle. Okay, so my answer is x values that are less than 0 or x values that are greater than or equal to 2. Let's put it in the other notation. Numbers from negative infinity up to 0. Notice the curvy bracket, the parenthesis, union with, oh, I made a mistake.
Gotta make a
I
square.
want a square bracket there. To infinity.
So those are always going to involve infinity and negative infinity.
Not always. Let's get to one where that doesn't show up.
Very pretty.
Let's find one. How about the one right below it?
See?
Yeah, the one right below it. And please make sure you're including this. I know some people have been like, oh, I don't like this. Sorry if you don't like it, but I'm asking you to include
It's
the
actually
number line representation. Usually people that are complaining about the number line end up just making tons of mistakes. I'm like, just please use the number line. Trust me. If not, just suffer through it for the short term. Okay, so C looks like this. All right. So, question is this time, what kind of numbers make this expression bigger than 3? Kind of a different, this one was asking when are we less than 3, so you can kind of already maybe intuitively tell that like, yeah, we're gonna be looking at some like a different kind of answer here. So anyway, let's solve it like an equation. Yeah, so let's do 2 steps at once. Treat it like an equation. Right? I'll show both steps. I'm gonna treat it like an equation. You can skip this intermediate step if you want.
It's just
Right? Yeah. So think of it like an equation and solve it. So to solve this, you multiply both sides by x minus 2. Cancel there. And so you get 12 equals 3x minus 6. 18 divided by 3, you get the answer 6. Something to think about, those of you that are going to pursue more advanced mathematics, start thinking about, can I solve this in my head, right? 12 divided by what makes 3? 12 divided by 4 makes 3. What would x have to be for this bottom to be 4? X have to be 6. That'll help you when you're taking, you get into Calc 1, Calc 2, Calc 3, just kind of help you make sure. A lot of times you have to show your work anyway, but it's good to be like, I know the answer before I even show my work. I know what the answer is. That makes sense?
Mhm.
Okay. Number line time. Number line time is best time.
Definitely 6.
6, good.
For sure.
What's the other number that has to go on here?
Okay,
So
2.
two.
Is it 2 because that's where the asymptote is?
Very good. So this thing, this is why, one of the reasons why I'm so keen on graphs at the beginning of the year. If you understand that this structure has an asymptote at 2, and you know that, oh, that means that this quantity can jump from positive to negative at 2, that informs your process that I have to consider that number when I'm like looking at the number line. So anyway, let's plug in some numbers. Let's plug in 8. Sure, plug in 8. 12 divided by 6 is not bigger than 3. So no. Frowny. How about a number between 2 and 6, like
3.
3? 12 divided by
That's correct.
1 is good. And then how about a negative or a number less than 2? So
One.
sure, how about 1? Oh, I have a negative number over here if x is 1, which is certainly not the case. So that means, and now again, can I have an open or close?
Close.
Open.
Open. You can't plug 2 into that.
And then a closed on. Wait. Oh yeah.
You can't, well, you can
'Cause
plug in
there's
6.
There's no line.
Yeah, if you plug in, exactly, yeah, there's no line. If there had been a little line there, we would have said closed up, but this is opened up. So my answer is, 2 ways to write this is my x value has to be in between 2 and 6, or I can write the interval from 2 to 6. Now you want confusing, doesn't that really looks like I'm describing a point in space, right?
Yeah.
But
How
I'm not.
would you, if both of them were closed circles, do that? It'd be 2 brackets. Okay.
Well, for this, if this problem, if say we put a little line there,
Mhm.
then just this guy would
Yeah.
have the
So it'd
bracket.
just be okay.
You're never gonna have a closed bracket if there's an asymptote value.
Okay.
All right, let's do one more to end the day. What?
Page. At home.
Huh?
Page is at home.
Kudos to her.
Yep.
Living the dream.
Yep.
You look more early or late?
We're late one more week.
Yeah, your finals were
Well, can I
really.
go to the bathroom?
What?
Can I go to the bathroom real quick?
Okay. We'll do one from, I guess we do one from this page. How about E, the one right below it? So we're going vertical.
That's fine.
This is our last one of the day.
Do we have early lunch today?
No, you just, your ability to tune things out is pretty amazing. I wish I had that power.
It is nice.
It's like 3 different people were just talking about that.
Were there?
Wait,
We're
so
late.
do we?
No,
It's
we
real
don't.
late,
We're late.
sadly.
I was not listening.
Sadly. Okay. Let's do this one a little bit more efficiently, okay? We're gonna be kind of speedy on this. Okay, so for what values of x is 5 over x squared less than or equal to 5? We got, yeah, right. So let's say you can solve this kind of fast. If you go, well, 5 divided by 1 would give me 5. So that means that my x value has to be plus or minus 1. My number line,
Okay, is there a 0 in there too?
very good, because the original guy has an asymptote at 0. Okay?
Now we've got 4.
This is where it's really helpful to know that what these graphs look like. Because if you know the graphs, you can kind of just see visually that when is this guy below 5? Well, over here and over here, right? Makes sense? To the right of 1, to the left of -1. So, or you can plug into this and test it out. So plug in a number bigger than 1. You're gonna find it works. So you plug in, say, 10. Same thing if x is negative, and you're gonna find that these two. Those ones are maybe a little bit less obvious, right? You gotta be like, well, if I plugged in like 1/2, I'd have 5 divided by 1/4, which is 20. 20 is not less than 5. So anyway, the answer for this would be negative infinity to -1, and then from 1 to infinity. Open circles again, of course. Oh no, I'm sorry.
They'd be closed.
I'm crazy. No, they're closed. My bad, guys. Sorry. Just testing you, obviously, right?
Yeah.
So this one we got the closed brackets. Because my number line representation's got to be closed circles. All righty.
Good job, guys.
Good job.